Hello everyone, my name is Valentine, the Biomatter Lab of the Free University of Brussels in Belgium. Now this presentation seeks to explore the so-called LIGNIN-FIRST biorefinery for the production of aromatics from biomass. In our case, the biomass selected is indeed the waste output mass due to the fact that the waste output mass constitutes a significant waste challenge owing to its high moisture content, high acidity, and indeed general difficulty of management. Now what we have done is to explore the possibility of employing ethanol as both a hydrogen donor and a solvent, right, to facilitate the solvolysis of lignin via the in situ pathway, while simultaneously facilitating the hydrogenolysis of the pomace lignin. Right now, hydrogenolysis is enabled by the breaking of the beta oxygen 4 bonds that exist between lignin molecules as a means to produce monomers of lignin, which are indeed aromatics that can be employed in the industry. Now, what we have done is that we have investigated the effects of the parameters of temperature, time, ethanol, water, solvent ratios, volumetric ratios, and of course, ion 3 ion mixed in combination with hydrogen peroxide as the Fenton catalyst. So the molar ratio in this case of these two constituents constituted fourth process parameter. Now, employing this experimental design, we're able to determine the effects of these process parameters and indeed the conditions of these process parameters that will facilitate an optimal production of the so-called aromatic oil, right? So what we have been able to show was that indeed you can optimize the aromatic oil yields from apple pomace while employing ethanol as both a solvent and hydrogen donor. We're able to optimize it such that we obtained an oil yield of about 24.6 weight% fraction with respect to the dry mass of the apple pomace initially processed. Right now, that is conditions of about 260 degrees Celsius, volumetric ratio of ethanol to water of 1, and of ion 3 ion ratio to hydrogen peroxide molar ratio of 100, and of course a time about 5 hours. We're able to optimize the yield of these aromatics. Now, this study has implications in the industry and the biochemical industry due to the fact that these industries have a significant dependence on aromatics for their operations. And of course, if we can expand this process to large-scale processes, the effects on overall climate change and indeed due to the reduced dependence on fossil aromatics will be valuable. Thank you for listening.